This project is an evaluation of green infrastructure on Radford University's main campus from 2008 to 2018. Green infrastructure is an urban design that is used to infiltrate stormwater and mitigate stormwater runoff. It reduces the amount of pollution present in runoff from urban areas. It is cost-effective, can ease the intensity of urban heating, prevent flooding, and provide many other environmental benefits. The purpose of this analysis is to model the green infrastructure on campus and analyze how it has changed over time. The green infrastructure used in this study is only green spaces and tree canopy cover. The other types of infrastructure include buildings, parking lots, and sidewalks throughout campus. RU's entire campus covers 204 acres within the city of Radford, while the main campus is only 86.2 acres. Radford University is located in Southwest Virginia, a few miles off of Interstate 81. This analysis was completed by first downloading data imagery from the USGS Earth Explorer using specifically NAIP imagery. NAIP is an aerial imagery program that captures images during the peak season of agriculture. These images were used as a reference to digitize the areas of buildings, parking lots, sidewalks, green space, and tree canopy cover. The first image here includes all features on campus in 2008. Figure 3 displays the infrastructure changes that occurred on campus from 2008 to 2012. The differences between the two images are colored in red. Figure 4 shows all set changes on campus in 2012. Figure 5 displays the changes that occurred from 2012 to 2018. The changes here are also colored in red. The 2018 image displays the most recent NAIP imagery and includes the set changes that occurred since 2012. The final image displays the overall changes that occurred from 2008 to 2018. All changes are shown in red. Within ArcGIS Pro, the area of each feature was calculated using the Calculate Geometry tool, which provides each individual digitation's area, and it also provides statistics that include a total area of sum for the entire feature class. The sums of all feature classes were added together to get the total acreage of all features on campus. In 2008, the total area of infrastructure features was 75.6 acres. These areas summed cover 88% of the main campus and a total of 32.96 acres, or 38% green infrastructure. There is a remaining area of 10.6 acres that was undetermined due to low resolution of the image that made some areas difficult to determine. This is calculated by 86.2 acres minus 75.6 acres. The remaining acres were not digitized. For 2012, the total area of features was 80.8 acres, leaving a remaining area of 5.38 acres undetermined. These areas summed cover 94% of the main campus. The differences between 2008 and 2012 have a total change of 10.3 acres. Of this area, there was a 5.23 acre increase of green infrastructure and a total of 44% green infrastructure on campus. For 2018, the total area of features was 80.7 acres, leaving a remaining 5.5 acres undetermined. The differences between 2012 and 2018 have a change of 11.98 acres. Of this area, there was a 0.8 acre increase of green infrastructure and a total of 45% green infrastructure on campus. From 2008 to 2018, there was an overall change of 22.3 acres. Of this area, there was a 6.03 acre increase of green infrastructure. After conducting a t-test within JUMP, confidence intervals were developed. Buildings had a confidence interval of 17.7 to 26.3. Canopy cover had a confidence interval of 6.2 to 9.1. Green space had a confidence interval of 23.6 to 47.1. Parking lots had a confidence interval of 6.3 to 27. And sidewalks had a confidence interval of 5 to 14.9. Since all acreage values fall within the confidence intervals, this proves that there is no statistical evidence that there are differences between each year. However, the graph above shows visual evidence that there are some differences between each year. By observing the graph, I conclude that over the years, GI has remained consistent on campus. although there are different types of green infrastructure. There was a decrease in the area of canopy cover, but an increase in the area of green spaces. The same can be concluded with impervious surfaces. There is an increase in the area of buildings, which leads to an increase in the area of sidewalks in order for people to have access to the buildings. In conclusion, over a 10-year period, there was no statistical evidence of changes on RU's campus for green infrastructure. However, visual observation can conclude that there were some changes that occurred. Utilizing the GI design in urban areas can ultimately reduce the effects of climate change and help to reduce a city's carbon footprint. Thank you.